Okay, good, Kiran. So the world coordinate means the coordinates of your object in the world coordinate system, and the device coordinate means the coordinate of your object inside your device. Means it's what are the coordinates of your object in your device. In conventional Cartesian coordinate system, referred to as a world coordinate reference frame, can be used to define the picture. Let's see what is the meaning of this. Suppose there is one object. Suppose this is your object in your world coordinate system, and now we are interested only this area. So what the object which is outside from your interested area, we will clip, or we will not consider the portion of this object. Okay, we are interested only in this area. Okay, so this the frame we will use is called window. The frame we used for clipping a particular region is called window, and the coordinate system which is given to your this object is world coordinates. This is the world coordinate, and this is the window in which we are interested. Okay. Means suppose there is an object and you want to capture the image of that object. So what you will do, you just select that portion only in which you are interested in, what the portion you want to take the image. Only you will select that portion. So that portion you're selecting is called the window, and this is your object, and you are only selecting this portion. Okay, so this portion is called window, and the whole object is called world coordinate, and your whole object is present in your world coordinate system. Then after selecting your window, in the selecting window or interested area, you map that area into your device. Your device may be your laptop screen, or computer screen, or maybe your phone. The size of your laptop screen, just consider it is a computer screen. So what the area you are shown the interested, you will map that area into your device. So you will map into your device with this. The device has its own coordinate system. This device coordinate. So now you are mapping your window into a device coordinate. So this device coordinate, this area which is present on your device coordinate is called viewport, where you view the image. So now this is your viewport. So ultimately what you are doing, just mapping your object from window to a viewport. So this kind of transformation we called window to viewport transformation. Ultimately this is happening. This is your object, and you selected this using this window and capturing only this portion which is inside your window. And after selecting that area, you just map your window into a device. In the device there is an area which able to display your images. So this area we called as viewport. Okay, so there's a four terminology. World coordinate, it is the coordinate of your real world object. And window, which we are showing the interest of that object. And device coordinate is the coordinates of your device. And viewport is the area where your object is displayed in your computer. Okay, so there is some there, as you can see, there v max x w min x w max y w min y w max. So this is the coordinates, this is your window, and this is the minimum value of x coordinate, and this is the minimum value for y coordinate. So we for the we're talking about the window, so we just given the name w min, means the window minimum for x coordinate, window maximum for x coordinate and here is the same. Y w means y minimum for window and y maximum for window. In the same way, for the device coordinate in the viewport, we just give the name convention as x v min, means it is the minimum for the window port in for the x coordinate is the same way. Okay, so now we will map our object, real world object, using window into a device in the device viewport. Is it clear? Is it clear? So for the window, we can say what is to be displayed in the this selected area is representing what to be displayed, means we are selecting the area of object which we want to display. So you can define your window as a what to be displayed, means when you capture an image, you select the area what is to be captured or what is to be displayed. In the viewport, you can define as where is to be displayed in the device, where is to be displayed. So you can easily differentiate window and viewport. In the window, we are selecting what is to be displayed, and viewport we are defining where is to be displayed. Okay. The one more thing is the size or the shape of your window not equals to viewport. It may be differ. This rectangle, as you're calling window, is different from the device coordinate or the viewport area. Means the shape of these two is not same. So when you applying the mapping, the size of your object may be minimized or maximized. The size of your object may be minimized or maximized. When your viewport is greater than your window, then your size of your object will be increased or maximized. When your viewport size is smaller than your window, then your object will be minimized. The size of your object will be minimized. It is depend on the ratio of your window and viewport. So what is our objective? Our objective is to find the view coordinates. Or ultimately our objective is to find the viewport coordinate to a given coordinate. Suppose there is one points is given, is coordinates are xw yw, and we want to map this point into our viewport. So this point is just called xv. So our objective is to find these coordinate, means the coordinates for viewport using or given coordinates of windows. Means ultimately our goal is xw and yw is given, and we want to find the corresponding coordinates for viewport xv and w. sorry, YV. So ultimately, this concept is called window to viewport mapping or transformation. So there is an just consider this is our window and this is our viewport, and there is a one object. This consider this a circle, which is right side in the bottom area. So when you map this object into your viewport, the size may be maximized or minimized depend on the ratio of your window and viewport. If the size of this viewport, as you can see, is smaller than the windows, then it will be size is reduced, but the respective or relative position is not changed. Here it is in the bottom of right hand side. This is also the bottom in the right hand side. The relative position is not changed, but size is changed. Okay, so there is an we are applying scaling on object. Using scaling, as you know, we scale up or scale down the size of object, but shape is not changed. Okay, okay, sorry. Shape can be changed. It depend on the value of sx and sy is the scaling factor. But in this mapping, the relative position is constant. When your point is here relatively in the window, so the same point will relatively in viewport, the same location. So how we can map this to viewport to window? So there is a one formula. Let's derive that formula. Let's consider this is your world coordinate system and this is your device coordinate. In the world coordinate system, there is a window. Let's draw one window. In the device coordinate, there is a viewport. The window and viewport may be same or may not be same. Okay. This is your world coordinate system. This is your device coordinate. This is your window and this is your viewport. And here there is one point is given in the window. The coordinates are x, w, y, w. In this point you want to map in the device. So the given coordinates are also the points y, v. Okay. This is your x, w min in the window. This is the x coordinate minimum, and here it's a x w maximum. Here it is y w min, and here it is y w maximum. Okay, and this is your given point. In the same way, the device coordinate, this is your x v min. We call it v because it's the coordinates is a viewpoint coordinates. X v maximum. Here it is y v min, and it is y v maximum. So these are the point. Now how we can map this, the formula. The our key point is a relative position. Should not change. Okay. When the relative position is not changed, you can write the formula as xw minus xw min y xw max minus xw min equals to xv xv min minus xv max xv min. You can see in this formula relative position is constant. This distance and this distance will be mentioned in the up, numerator, and this scaling factor, this difference, this factor is common. So, we are maintaining this scaling. Okay, so we can write this formula in this way: xw, which is given point, and xv is derived point. We are pointing this coordinates. Okay, the same formula you can write for the y coordinate. Y w minus y w min y w max minus y w min equals to y v minus y v min equals to y v max minus y v min. Again, you can see we are maintaining this relative position. This and this. This is the boundary line. This is the boundary line. And this is the boundary line. And this is the boundary line. So the position of this point from its boundary, we are fixed. When we fixed the distance from your boundary, both the boundary, means the relative position is fixed, is not changing. So using this formula, we can write ultimately what we need to find: value of this and value of this. Ultimately, what we are going to find: this coordinate x v y v. These value we need to find. So let's simplify these equations. Please speak. Pakshit Kothari. Pakshit, do
Yes,
you have,
sir.
yes, please ask. Pakshit, do you have any doubt?
No, sir.
Okay, so mute your mic.
Okay, sir.
Okay, so xv minus xv min equals to, you can write xw w min divided by xw max minus xw min into this term xv max minus xv min. Here, these two you can write as you can write this term here: xw max minus xw min. So this term you can see xw max minus xw min divided by w max minus xw min. This term you can call as the scaling factor correspond to x-axis. So you can write xw minus xw min into sx is the scaling factor correspond to x coordinate. Okay, then transfer this term to the right hand side. Xv equals to xv min plus xw minus xw min into sx. this is the question for x coordinates for your window port. The same you can calculate for the y. You can write, you can directly you can write yv equals to yv min plus yw minus yw min into scaling factor corresponds to y axis. So we have derived the formula for calculating this coordinates xw vw when we have given this xw and yw. When we have given these points, we can calculate the corresponding point for the viewport using these formulas. Is it clear? Is it clear? If you have any doubt, you can ask me. No doubt.
Sir, how you write the scaling factor corresponding to x?
Again, please repeat, Ashwarya. Please repeat.
Write the x I equals to max minus xp min.
Okay, okay. So here, as you can see, this term xv max minus xv min, xv max minus xv min, sorry, xv max minus xv min, this scale divided by this scale factor means this is the ratio of your window. We are giving this is a x code, sorry, what once again, xv max minus xv min, xv max minus, sorry, xv max minus xv, xv max minus xv min divided by xv xw, again I'm just sorry, xv max minus xv min, this scale divided by this scale means this is the scaling correspond to x-axis. Here this difference and this difference corresponds to x-axis for the window and viewport. And when we the right sorry, for the y, this is the scale for the y, viewport and window port. When this difference you just call xv and you can call yw, so xv divided by xw, this is scaling. If this size of this in the window is this much, the size of your viewport this much, so this is one kind of scale. In the same way, the size of viewport is this yv and this is wv. So when your viewport is increased this much, your viewport is increasing this much, your window is increasing this much. So this is one kind of scaling corresponds to y-axis, and this is scaling corresponds to x-axis. So just give the direct name sx and xy. Okay, you can also write this the whole term here as well. Is it clear?
Yes, sir.
Here this sx and sy are the scaling factors corresponds to x-axis and y-axis. Is it clear? So let's solve an example. It will be more clear about the transformation from window to viewport. Let's just consider the given window. Let's consider this is your window. The coordinates of your window, coordinates means the boundary of your window is considered as 20, and it is 80, and it is 30, and is considered as 60. This the boundary means x w min is 20, x w max is 80, y w min YW min is 30, and YW max is 60. This is the boundary for window. And same is given for the viewport. Suppose your device is like a rectangle. Sorry, square. Okay, then the coordinates or the boundary of your viewport is just considered as a 40, and it is just considered 60, it is 30, and it is 50. So this is your x v min, it is x v max, it is y v min, and it is y v max. Now we have given a point, we are mapping. Consider the given point is x w y w is 40 and 45. Just consider the given point which is in window is 40 and 45. Just consider it here xw vw, and we want to map this point from this position is from window to our viewport. This is our viewport. We are mapping this point into our device coordinate. This is our world coordinate, where is the object, your object present in the real world, and we have captured the image of your object using window. And now after capturing the window image using window, we want to transfer this point into a device in the device coordinate. This is our viewport, which is present on your screen or the display, and where it is to be located. So we have to find this coordinate x v and y v. These coordinates we have to find. We are going to find. Okay, this is our mapping. Let's apply the derived formula and calculate. A formula, if you remember, even if you not remember, you can write. If you know the relative position is not changing, so you can write x w minus x w min. W min, this position. This is the xw, and if you divide xw min, so this is the difference, and this difference is equal. So you can write in the here x v minus, you will write x v min in the denominator. This difference in the scale of your window and the sorry, width of your window and this width of viewport. So x w max minus x w min, and here it is v x v max minus x v min. Put the value xw is given as 40 minus xw min. which is 20 minus xw max, which is 80 minus xw min 20 xv. We are finding an xv min, which is 40, and xv max, which is 60 minus xv min 40. Calculate 40 minus 20, 20, 80 minus 20, 60, xv minus 40, 60 minus 40, 20, xv equals to, let's consider 3 and sorry, get 20 by 3 plus 40, it is around 6.46.33. Okay, so xv you have find as 46.33. Let's calculate yv. So the same formula you apply. Yw minus yw min, yw max minus yw min equals to yv minus yv min, yv max minus yv min. Put the value yw, this is given, which is 45 minus yv min, yw min, yw min is 30 and yw max is 60. Just remember, which is 30, and it is 60 minus 30, and yv we are ultimately finding, and yv min this 40, 30 and 50, it is 30 minus 50 minus 30. Calculate 45 minus 30, it is 15, 60 minus 30, it is 30, yv 30 20 50 minus 30 is 20. Okay, is 2, just 10. So 10 into yv minus 30, ultimately you can write yv equals to 40. So you have calculated our value, xv equals to 46.3 and yv is 40. Our given point, our derived point is xv yv is 46.3 and 40, it is 40. The coordinates of this point is 56.3 and here it is 40. Okay, so using this formula we can map our window point to a viewport points. Is it clear? Is it clear to all of you?
Sir,
Um,
it is given that the viewport is given. Can we find the window?
One minute. Yes, please speak
Sir,
again.
sir, if we have given the viewport, points of
Hmm.
viewports,
Hmm.
and the coordinate we get xv and yv is given, then how we calculate the xw and yw?
No, it is not possible. The reverse process is not possible. Suppose we have just please understand the concept. We are mapping window to viewport. Means we have a real world object is present, and we are capturing the image using our mobile phone or any camera, and this is our interested area we want to capture. And after capturing the image, we want to map this into our device. It's maybe mobile phone or your computer screen. So your real world object map into our screen. Suppose you want to capture image of a one person, so you have captured the image and you have map into your mobile phone. But reverse process is not possible. Suppose we have a photo of a one person in your mobile. Can you come out this photo into real world? Suppose there's a photo of one person. Suppose Sachin Tendulkar. Can you reverse of this process? Can Sachin Tendulkar come out from your mobile phone in the real world? It is not possible.
I got it.
There's a one concept. We are mapping real world into our mobile phone, or sorry, in the screen or device. The device image cannot come out from the real world. Okay, is it clear? Okay, so any other doubt? Do you have any other doubt? Okay, so please write the attendance in the chat. Write T for tiger. Write T for tiger in the attendance, for the attendance in chat box. If you have any doubt, you can ask. So in the next class, we will discuss about the clipping, point clipping and line clipping. So before you join the class, next class, please read this clipping from internet or any books what you are available. Okay. Okay. So write the attendance and you can leave the class. If you written the attendance, you can leave. Okay. Thank you.